This is just a very quick follow-up video to the previous one in which I showed the ROM card for this HP9830A desktop calculator that I'm attempting to repair, and I indicated I was going to write some test programs to start testing the hardware. So that's what I've started doing, and this is just a, as I say, a quick video to show how I'm going about this. So I'm writing programs like this. This particular program is to test the RAM card or parts of it, and I'm writing various programs like this to test the display, the keyboard and the different parts of the system. I have the main system ROM removed, of course. This is just the test code that I'm running, and just to give you a quick demonstration of how this works, this particular program just loads a couple of pointers, uses the B register as an index register into RAM, and then it writes a value of 4 A's to a particular RAM location, reads it back, checks that what it's read back matches what it's written, does the same thing with 5555, and I'm sure you're all aware that's just the complementary bit pattern, so we're testing all the bits in the RAM, and it goes through both those patterns and then it loops back and increments the address that it's testing, and then decrements the counter. So we just set the counter at the beginning to tell the program how many times to loop round, in other words how much of the RAM to test, and then if there are any errors it jumps to an error loop and stops, and if it succeeds it jumps to another loop and just continually cycles around that loop in this particular mode. So I'll demonstrate that very briefly. I use the analyzer to monitor what the results are. I've got the trigger set to cycle 100 times before it captures, and that's because I've got the counter in the program set to 100. So in other words, it's going to test 100 RAM locations. I'll arm the analyzer, power up the machine. Again, I can turn it off because it's finished the test, and now we can look through and see if it's been successful. Now first, we know it's been successful because it hit the trigger point. In other words, it was successfully looping 100 times, and the address that we are triggering on is one within the test loop, not in the error loop. So in other words, if it's hitting this particular address, then it was a successful loop. And then once it captures, as it has done here, it does a few more checks, and then ultimately it will jump to the end of test wait loop, which is at address 28. You can see it here just looping round continuously because it's finished the test. Now I mentioned previously that the ROM card has bank switches, so of course I have a second test in this card. I'll just switch the ROM into the second test. It's a very similar test. The difference here is that instead of stopping at the end of the first pass, there's a difference in the jump back address, and it will go back to the start of the program at the end of the test and loop round again and continue the test. In other words, it means we can test continuously. So if we do exactly the same thing, I'll arm the analyzer, hit run, and as you can see it was successful and it completed the 100 checks. But of course, because it's going continuously, what I can now do is set it to run the test more times. So I've now got it set for 10,000 cycles. If I arm the analyzer, power up the machine, you can see it counting down in the top right, and it's successfully completed all 10,000 loops. So in other words, it's tested those 100 memory locations in RAM 10,000 times, and it hasn't detected any errors. I did find some errors on the ROM card. There were several that I've corrected. They were fairly minor things. One of the level switching transistors was open circuit, wasn't providing the proper output, and the pre-charge circuit wasn't working correctly either. It was working but intermittently. There are still problems on this machine, but this approach is going to obviously make it easier to pinpoint where those are. What I intend to do once I've finished all this is make these test programs available, so if somebody else has one of these machines and they want to use this same technique, then it should save a lot of time in tracking down faults. So let me know if you're interested in that. Okay, that's it for this video. I'm going to carry on the testing and hopefully sort out the remaining issues.